Okay, so this is what we have started the first unit of our subject introduction. Still, we are in that the first point, which is related with the SCR, and that today we are going to finish it up. So, in this, the construction, the working, the VI characteristic, and the turn on methods, how we can turn on the SCR, and the applications also we have seen for the thyristor family or the SCR. The another name for that one is the SCR. Today we will talk on the turn off methods of the SCR. So they are bifurcated in the various classes, and what is this classes? So that today we are going to learn. So before that, just a quick review of the yesterday's session, that just put the answers for these uh, terminologies, so that I will come to know that you have gone through the yesterday's session some preparation. If you are noted down in the notebook, so that way that is must now onwards, but that will be beneficial for you only. So just quickly take 1 minute and recall and give the answer for these questions. That is the terminology. Okay, so many answers I am getting, but these answers I just feel like that they are copy pasted, but no issue. At least you have gone through the this to the documentation yesterday you received. So with that, we will go for the answers. That is, the first question was the what is latching current. So what we discussed yesterday, that is the latching current. It is nothing but the minimum anode current required to maintain the on condition of SCR. म्हणजे SCR ऑन कधी होतं, तर एक तर ॲनोड टू कॅथोड व्होल्टेज त्याला फॉरवर्ड बायस केलं पाहिजे, आणि प्लस गेट करंट दिला पाहिजे, आणि नंतर गेट करंट तुम्ही काढून घेऊ शकता. पण एकदा SCR ऑन झाल्यानंतर तो कंटिन्यू राहण्यासाठी जे मिनिमम करंट लागतो, सो दॅट इज नोन ॲज दिस पर्टिक्युलर द लॅचिंग करंट. Next one was the holding current. So holding current is what? Again, it is the minimum anode current below which SCR will go in a forward blocking state or mode. So this holding current च्या खाली जर करंट गेला तर SCR हा ऑफ होतो. ऑफ होतोच म्हणजे काय, तर फॉरवर्ड ब्लॉकिंग मोड मध्ये जातो. So this is what the holding current is. The third one is the TGT. That is the gate timing. So what is this timing? So the time it takes for a gate pulse to send the SCR into conduction mode. म्हणजे SCR कंडक्शन मोड मध्ये जाण्यासाठी जेवढा टाइम लागतोय गेट पल्स दिल्यानंतर, सो दॅट टाइम इट इज नथिंग बट द TGT. TQ. So this is the off timing. Off timing means what? Of SCR. Key, the time it takes for SCR to start blocking current after external voltage has switched to negative cycle. So this is the answer in the reference of AC source. म्हणजे जर इनपुट तुम्ही जर AC दिलत तर हे उत्तर आहे त्याचं, की निगेटिव्ह सायकल चालू झाली की ऑटोमॅटिक तो SCR ऑफ होणार. बट इन द केस ऑफ DC व्होल्टेज सोर्स, सो इन दॅट केस जर तुम्ही पोलॅरिटी चेंज केली, म्हणजे फॉरवर्ड बायसचं रिव्हर्स बायस केलं, म्हणजे रिव्हर्स व्होल्टेज त्या SCR ला जाणार आणि त्यावेळेस तो ऑफ होणार. सो हा जो पिरियड आहे फॉरवर्ड बायस टू रिव्हर्स बायस झाल्यानंतर SCR ऑफ होण्याचा, सो दॅट टायमिंग इट इज नथिंग बट द TQ. हे पॅरामीटर्स, few of the parameters we have seen yesterday. Now this is the one previous slide yesterday, that how the SCR can be get turned on, so that we have seen yesterday. And with that we will go ahead today with the SCR commutation. So first question arises that what is this commutation? So on methods we have seen how to make the SCR on. In the same way, how to make now SCR off? So for that the different word they have used, so that is nothing but commutation. So the first line also it is written over here, that is the turn off process of an SCR is called commutation. मग हे कम्युटेशन म्हणजे SCR किती प्रकारे ऑफ करता येतो. तर जनरली yesterday only we have discussed की जर फॉरवर्ड करंट जो आहे तो होल्डिंग करंट पेक्षा कमी झाला की SCR ऑफ होतो. इन जनरल वेज, दिस आर द वेज. त्यानंतर रिव्हर्स व्होल्टेज दिलं की SCR ऑफ होतो. गॉट इट? सो दिस आर द बेसिक वेज or the terms conditions for what the SCR can made off. Just wait for 1 minute. Net disconnected. Okay, so we were talking about the commutation. So first way is that की एनोड करंट जर होल्डिंग करंट पेक्षा कमी झाला की SCR ऑफ होतो. आणि दुसरं काय की रिव्हर्स व्होल्टेज मस्ट बी अप्लाइड अक्रॉस द SCR, की त्यांना सुद्धा करंट ऍक्च्युअली तो कमीच होणार आहे होल्डिंग लिमिट पेक्षा, आणि इट विल गोज इन अ फॉरवर्ड ब्लॉकिंग स्टेट, म्हणजेच ऑफ होणार आहे. बट the commutation methods are classified into two major categories or the two major types. First is natural commutation and another is the forced commutation. So what is this natural and forced? That we will see the scenarios depending on what they are categorized. So first, it is the natural commutation, which is applicable when the input supply is AC. Input supply is AC. So in natural commutation, what is happening? The source of commutation voltage is the supply source itself. So as it has been shown in the diagram, so you can see it. की SCR आहे, पुढं त्याला इन सिरीज लोड कनेक्ट केलेला आहे आणि इनपुट सप्लाय जो आहे तो सायनोसॉइडल आहे. That is the AC supply we have provided. So this method is also known as the source commutation किंवा line commutation किंवा class F commutation. So this is important, the other parameters related to natural commutation. तर ह्याच्यामध्ये काय होतं? So definitely this is the method of making SCR off. मग त्यासाठी SCR ऑफ करण्यासाठी पहिल्यांदा तो ऑन झाला पाहिजे. इज इट ऑन कसा करणार SCR? सो इफ यू आर एबल टू सी द कर्सर यू कॅन सी हिअर. तर ह्या SCRच्या गेट टर्मिनलला गेट करंटची एक पल्स दिली की हा SCR होतो ऑन. SCR ऑन झाला की करंट व्हायला सुरुवात होते. सो इन व्हॉट डायरेक्शन द करंट इज गोइंग टू फ्लो? दॅट इज फ्रॉम दिस पॉवर सोर्स to the SCR, to the load, and back to the power source. So this will be the way of flowing the current. Got it? But the graph, it is already shown here, so you can also parallelly check out. But this is for the positive half cycle. When the input source goes in a negative half cycle, so that time whatever this SCR will get the voltage, so that will be negative, and that is the reverse voltage will be applied to the SCR, and SCR will go in a blocking mode. That is reverse mode, it will go and no current is going to flow through the SCR, and that is the off condition. So that's why the name is given natural commutation. ह्याच्यात आपल्याला काहीच करावं लागत नाही ऍडिशनली. पॉझिटिव्ह हाफ सायकल आली की तो ऑन राहतोय, निगेटिव्ह आली की ऑफ होतोय. परंतु परत ज्यावेळेस पॉझिटिव्ह येते सायकल, तर त्यावेळेस गेट पल्स ही कंपल्सरी आहे. तो ऑटोमॅटिकली ऑन होत नाही. गेट पल्स इज कंपल्सरी. सो दॅट इज व्हॉट इट इज शोन इन दिस पर्टिक्युलर ग्राफ. So this is the VS, that is sinusoidal signal. This is the IG, that is gate current or gate pulse we are talking. तर प्रत्येक पॉझिटिव्हच्या सुरुवातीला गेट पल्स ही आलीच पाहिजे, तरच तो SCR ऑन होईल. अँड दिस इज द IL, म्हणजे करंट थ्रू लोड. सो फॉर पॉझिटिव्ह इट इज गोइंग टू बी all the positive half cycle we will get through the load. So this is called the natural commutation or the source commutation or line commutation. समजलं natural commutation? This is the natural commutation. But this is the case of जर alternating source असेल तर supply voltage. पण जर इथं DC जर supply दिला तर, so in that case how to make the SCR off? मग त्यावेळेस आपल्याला फोर्सफुली तो SCR ऑफ करावा लागतो. म्हणजे ज्यावेळेस वेळ येते त्यावेळेस. मग त्याच्यासाठी काय प्रोसेस आहे? सो वी आर गोइंग टू यूज द एक्सटर्नल कॉम्पोनंट और द एक्सटर्नल सर्किटरी add to this particular SCR so that they will have a control on the on off of this SCR, and that is called the forced commutation. It is known as the forced commutation. So this is what it is mentioned over here. In case of DC circuit, there is no natural current 0 to make it SCR off. So in such circuit, forward current must be forced to 0. मग ते forcefully 0 करण्यासाठी आपल्याला additional circuitry जोडावं लागते, and they are called the commutating component. Commutating components, and they are nothing but our regular component, that is the capacitor and a inductor. just remain. So this force commutation is classified into different types such as class A, class B, class C, and class D. Force commutation. Got it? And what is this A, B, C, D? So different methods are there. That is the थोडंसं सर्किट चेंज केलेलं आहे. SCR तर ऑफ करायचं आहे आपल्याला काही करून. तर मग तो कसा केला जातो वेगवेगळ्या ऍप्लिकेशन नुसार. सो दे हॅव कॅटेगराइज इन क्लास ए, क्लास बी, क्लास सी आणि क्लास डी. So one by one that we supposed to just check out today. Okay. So first we will see the class A force commutation of SCR. So this is the diagram or the setup for class A commutation. So what is this class A commutation contains? So just check out the first diagram, and if it is possible, just if you are having the pen and paper with you, so draw this diagram, because आपल्या हाताखालनं एकदा ह्या डायग्राम गेल्या म्हणजे थोडंसं परीक्षेमध्ये सोपं जातं, because now we have to face the offline exam. So take 1 minute and just draw it. Put the heading, that is the SCR turn off methods. त्याच्यामध्ये नॅचरल कम्युटेशन आणि फोर्स कम्युटेशन, आणि फोर्स कम्युटेशन मध्ये क्लास ए, क्लास बी, क्लास सी, क्लास डी. सो फ्रॉम दॅट दिस इज द फर्स्ट, दॅट इज क्लास ए फोर्स कम्युटेशन. आणि ही डायग्राम एनी वन ऑफ देम. ए मध्ये काय आहे ह्या डायग्राम मध्ये की लोड इन पॅरलल विथ कॅपॅसिटर, आणि दुसऱ्यामध्ये लोड इज in series with capacitor. That is the only change. Other things are same. So anyone you can choose for the implementation of this, making the SCR off. So draw the diagram. I will wait over here. Okay. So this method is also some another name also they have given depending on this the scenario, that is the self commutation or resonant communication or load commutation. So depending on this particular scenario or the working of each one, so these names are they have alternatively given to it. So that also we supposed to remember. Now the question is how it works and how it makes the SCR off. So for that you should just listen carefully, and in your words you supposed to note down the steps. Okay, how this is going to be make the SCR off. So first it is the class A commutation. So in that, if you are looking the additional component L and C, that is the inductor and capacitor, are used in a series with SCR. So that should be the first statement. That is, in class A commutation, the commutating components are L and C, which are connected in series with the your SCR, to whom we have to make it off. So how it works now? Working. So whenever we are providing the VDC, that is the input DC supply, when we are giving, and the SCR we are making on. So SCR making on means we have to give a gate pulse. That time only this particular SCR is going to be become on. So when the SCR will be on, this capacitor C, as its behavior, it is start to charge, and the charging path will be through L, SCR, and towards the positive of a battery. So this capacitor will start charging and up to the maximum Vs or the here VDC. So maximum whatever the voltage we have applied, till that the capacitor will charge. And once the capacitor will charge up to the maximum Vs, that is the input supply voltage, so that time it will stops the charging. It will stops the charging. And at the same time the inductor is also storing the some charge. Is it? Because that is the property of the inductor. It will stores the charge. And due to that, this particular polarity of capacitor is going to be starts in reverse. That is plus minus, it is going to reverse, and capacitor starts discharging through the load RL. Capacitor is going to start to discharge through this RL. And during that discharging of the capacitor through this RL, the reverse voltage is going to be produced through SCR. Through SCR. That is, the reverse current is going to flow through this SCR. And as the reverse current is going to flow, so definitely the SCR will becomes off. Because whenever the reverse current means what? The minimum current, that is less than 0. And definitely this reverse current is less than the holding current. And once this level is goes below the holding current, this SCR will becomes the off. So this is how it is going to becomes the SCR off, as this capacitor is going to be discharged. At the same time, when this capacitor reaches to the maximum VDC, that is the input supply, so that's inductor is, as its works is to store the charge, so that is also going to be used for the commutation. How? That is, it is going to be used as a reverse charging. The capacitor will charge to plus VDC, then it will discharge through RL, and afterwards the charge in L, that is inductor charge, makes that capacitor to charge in a reverse direction. And once it starts in a reverse direction to discharge charge, that SCR will goes in a off mode. And this is what the SCR will becomes off, and this is what the class A commutation is there. So what are the steps you have noted down? So first is SCR should made on. Second step, the capacitor charges up to plus VDC. That is the maximum this input voltage. Third step, polarity of inductor changes and capacitor will charge in a reverse polarity or in reverse direction. And the current through SCR will goes or becomes 0. And next step, when the current through SCR becomes 0 or less than holding current, the SCR becomes off. This is the simple way of explanation of this class A commutation. So you just listen afterwards, just note it down in your words, and that will be very clear to you afterwards. Okay. So next we will go for the next type of commutation, that is class B commutation. So what is this class B commutation? It is also similar to the class A only the arrangement is changed. Arrangement of this commutating components is been changed. So this is also a self-commutation circuit in which the SCR is achieved automatically by L and C component. Once the SCR is turned on, The LC resonant circuit is connected across the SCR, not in a series. So in class A, it was in series. Here it is in a parallel with the this SCR. So that is the only change they have made. So what is the effect of making this particular change, and how it is affect on the working, and how it is going to make the SCR off? So for that also we supposed to just go through the various steps. That is, the first step definitely it will be the that the when you are giving the input supply, the capacitor starts charging through the part of this particular why this is happening, oh, don't know. Okay, so we were talking about the class B commutation. So in this, the only the change is made, like the components, commutating components L and C are in a parallel. So the steps of this particular working is that whenever you are giving the input supply, the capacitor starts charging through the path of this particular, see the cursor, through this inductor towards the positive of the battery. So that will charge up to the maximum VDC. So that is the first step it is going to happen in this case. Second step, what is going to be happen, okay, we have to make it SCR on by giving the gate trigger. And once the SCR will be on, so that time, as per this particular current analysis or that, so in two loops current is going to flow. So which are these two loops? So E plus, that means the battery is positive, to the L, to the C plus, then C minus, and then RL, and then to the minus E. That is the minus terminal of this particular VDC. So this is the one loop through which the current is going to flow. But as the SCR now we have made on, so the other loop is also going to be present over there, that is E plus SCR RL and minus E. So this is the another loop. This is the one, and another is the this second. So in two loops the current is going to be flow when the SCR will be on. Now the capacitor starts when it reaches to the maximum plus VDC, so it will get a path. As this SCR is going to be on, so SCR will start discharging. Through what? Through L, this SCR, and this one loop. If you can see the cursor. So here, through this loop, the SCR is going to be starts discharging. And once this particular discharging is going to be start, and when fully discharged, the charges on reverse polarity is going to be start. Means what? Due to L. Because whenever discharging, this L is storing the energy. L is storing the energy, and when C is fully get discharged, it will change the polarity, this plus to minus and minus to plus, and it will charge once again the capacitor, but with reverse polarity or the reverse voltage minus voltage, it is going to start charging. And as the reverse voltage comes across the SCR will become off. As the reverse voltage comes across the SCR, it will becomes the off. So this is what the working of particular class B commutation, that is by using the commutating component L and C. So what steps you have noted down? So I will just recall it. So first step, the as a general behavior, the capacitor charges to the plus VDC. Second step, when we make the SCR on, the current flows in two loops. So first, as I told, that E, L, C, R, L and E. And another one, that is E plus SCR, RL and the minus of this particular battery. So up to the maximum VDC, the capacitor charges. But afterwards, as the SCR goes on, it gets the path for discharging. And through this L and SCR, it starts discharging. Okay, so capacitor discharges up to 0. But afterwards, the energy in the L so starts the capacitor to recharge, but in a reverse direction. That is, the reverse voltage will appear across the SCR, and once the reverse voltage is appeared across the SCR will become off. So this is how the class B commutation will work. So just note it down in the same way. Afterwards, just go through it so that you will be clear more about this class B commutation. In the similar way, a little modification they have made to get the class C commutation. That is also known as complementary commutation. So the setup is as shown in this particular diagram for the class C commutation of SCR. So in this type, the main SCR is connected in series with the load and another complementary SCR. Another second SCR is also been used. Sometimes it is been known as a auxiliary SCR or supporting SCR or additional SCR or complementary SCR. So different names are there for such situation. But here the most popular is the complementary SCR. It's connected in parallel with main SCR. So here SCR2 is a complementary SCR which is connected in a parallel with the SCR1. Now see the connections carefully. Draw these connections also in your notebook. Give the name class C commutation. How it works and how it makes the SCR1 off, because our main target is to make the SCR1 off. But for that, in this method, the help of SCR2, again one more SCR they have added over here. So definitely after the SCR1, SCR2 also has to make it off. So like this only, it is the task to this for this class C commutation. So how it works? So definitely we will see the step by step. So first of all, you just draw this diagram by the heading class C commutation. The positive and negative of capacitor is important. So you will say that firstly the positivity is shown to the right side. So why it is? So it is an assumption only that in that direction only the capacitor is mounted in the circuit, and accordingly the explanation is there. Okay, so how it works, the class C commutation. Now first step as it is there, so SCR1 and SCR2 are in a off condition both. That means there is no charge in the capacitor. There is no charge in the capacitor. Now, as a part of this making off the SCR1, so we have to make it on. So first step is we have made the SCR1 on. So as the SCR1 becomes on, this input voltage supply is also provided, so current is going to flow in again two loops. So what is this loop? E plus, see the cursor, E plus through RL. What happened? E plus to the RL to the SCR1 and back. So this is the one loop through which the current is going to flow. And another one, that is E plus, and this R, SCR2 is off right now. So through this capacitor, through this SCR to the negative of this supply. So this is the second loop through which the current is going to flow. Now, as we are talking about loop 2, so capacitor got the path for charging. So through this R, it is going to be charged towards the input battery supply. And that time, whatever the current is there, so that becomes the 0 in loop 2. Because capacitor is going to be start charging towards this particular battery source. And once it goes to the maximum of this voltage, that is the plus VDC, so it will start charging, and as it starts stop the charging, so the current will be in that loop will be 0. So only one loop is present now after the uh, fully charge of a capacitor. So which is this loop remain? So this is E plus RL and SCR1. Now we have to, the SCR is on, the current is flowing. Now we have to make the SCR1 off. So for that we have to start SCR2. We have to start the SCR2. And once the SCR2 is made on, so that time the SCR1 will goes in a reverse bias. SCR1 goes in a reverse bias, and that is what the SCR will become off. Because the capacitor gets the path, another path for the discharging through this SCR2. In this way, see SCR2, and towards this it is going to be discharged through this, and when it discharged through this, the reverse voltage, whatever it is there in the capacitor, it will appear across the SCR1. And once the reverse voltage is applied through across this SCR1, it will turn off. So that is the class C commutation. Okay, till here only. But as I told, another one more SCR is been added. So to make it off, so that is also required. SCR2 आपण वापरलाय तो SCR1 ऑफ करायसाठी. SCR1 आता ऑफ झालेला आहे, परंतु SCR2 ऑन आहे ना, त्याला आपण ऑफ करावं लागेल. So the next part is that, the remaining part is that, when the T1, that is the SCR1 goes off, म्हणजे हे ओपन सर्किट झालं. Got it? But still two loops are there through which the current is going to flow. And these two loops are E, RL C SCR2 and this one. See the cursor through RL, C SCR2 and back to battery. Another loop is that E R SCR2 and here. See the cursor. SCR1 ऑफ झाला तरी दोन लूप्स मधून करंट फ्लो होत आहे. So due to that, what is happening? So the capacitor once again reverse the polarity. Capacitor reverse the polarity and charges towards the negative supply. Charges towards the negative supply. And once it is starts to charge towards negative supply, so that reverse voltage come across the SCR2. That reverse voltage or the reverse current is going to be appear for this SCR2. आणि ज्यावेळेस हा रिव्हर्स करंट होल्डिंग करंट पेक्षा म्हणजे SCR2 च्या होल्डिंग करंट पेक्षा कमी होतो त्यावेळेस SCR2 सुद्धा ऑफ होतो. And thus the SCR1 and SCR2 both are now becomes in a or goes in a off condition. And this is how this particular class C commutation is going to be work. And the last one now, that is the class D commutation. So here again some modification they have made, that is they have used L and C are the commutating component, but in addition to that one normal diode is also they have used for the operation. So this is also known as the auxiliary commutation because auxiliary SCR is been used over here. In this, the main SCR is commutated by the auxiliary. In the last one also the same. The main SCR with load forms the power circuit while the diode D, inductor L and capacitor and the SCR2 forms the commutation circuit. Capacitor is there. In both it is going to be there. That is त्याच्यामुळेच तर चार्जिंग आणि डिस्चार्जिंग होतंय आणि डिस्चार्जिंगच्या वेळेस तो रिव्हर्स व्होल्टेज तयार करतोय की जे SCR टर्न ऑफ करायला मदत करते. So this is the what scenario is there for class D commutation. So first draw this diagram so that I will explain and you can note down the steps. Here also two SCRs are there. One is main SCR and another one is a auxiliary SCR. By using auxiliary SCR, we are going to turn off the SCR1 and again the capacitor is used to turn off the SCR2. So draw the diagram. Okay. Now how it going to be work? So definitely for this the assumptions are required, that is the capacitor's polarity and direction of that diode has to be assumed. In this direction only it is going to be put as a part of design. So in class D commutation, the first step is that we have to make the SCR2 on. That is the auxiliary SCR, we have to made it on. So assumption is SCR1 is already on. The assumption is SCR1 is already on. So the first step in this class D communication is to make SCR2 on. कसा करायचा तर गेट पल्स दिली की तो ऑन होतो. Now the current is going to be flow via, see the again the cursor, that is plus E, that is C through SCR and through RL to the this battery. So this is what the path you can check. through this diode it will not work because this is in a reverse direction. So through C SCR2 RL it is going to flow the current. In the same way, this capacitor is started charging, and when it reaches to the plus max VDC, so that time it will start the charging. And once this particular charging is going to be stopped, so that time it will becomes the off this capacitor, and it will works as a open, and due to that this SCR2 goes in a off condition. Okay, so this is the first part. Now at the same time the SCR1, our main target is to make it the SCR1 off, and if that SCR1 is still on, so the current is going to flow through E plus the RL and through this SCR1 RL, so this outer loop the current is still going to flow. Got it? At the same time the another one loop is going to be formed because now the capacitor is charged, fully charged. So C SCR1 L D C. So this is one more loop is going to be formed for the passing of the current. So one is outer loop and another is this inner loop through which the current is going to flow. But at the same time, if you are looking the combination of for loop 2 L, D and C. So this LC oscillation, that is it will creates the oscillation and it will create the oscillations. Oscillations means the nothing but the combination of positive and negative cycles. So in positive half cycle the diode will be on, and in negative half cycle the diode will be off. So that is what the capacitor is going to be start discharging. At the same time the inductor will start storing the charge. ज्यावेळेस सी डिस्चार्ज व्हायला लागतो त्याच वेळेस इंडक्टर स्वतःमध्ये चार्ज साठवून ठेवायला लागतं. सो दिस इज व्हॉट द नॅचरल देअर फंक्शन्स आर. आणि कॅपॅसिटर टोटली डिस्चार्ज झाल्यानंतर ह्याच्यातला जो चार्ज आहे एल मधला, सो इट विल स्टार्ट चार्जिंग द कॅपॅसिटर. जसं ह्या बॅटरीमुळं कॅपॅसिटर चार्ज झाला होता तसंच आता ह्याच्यात जो अल्टरनेटिंग करंट स्टोअर केलेला आहे इंडक्टर मध्ये, तर त्याच्यामुळं हा कॅपॅसिटर स्टार्ट्स चार्जिंग बट इन रिव्हर्स डायरेक्शन. म्हणजे ह्याची पोलॅरिटी चेंज होते, प्लस मायनस मायनस प्लस. अँड ड्यू टू द रिव्हर्स व्होल्टेज अक्रॉस दिस कॅपॅसिटर अप्लाइड टू दिस SCR1. हे रिव्हर्स व्होल्टेज ह्या SCR1 च्या अक्रॉस अप्लाय होतं आणि हा SCR1 ऑफ होतो. And this is what our target is, to make the SCR1 off. So this is how this class D commutation is going to be used. So I will just recall the steps. What are the steps? पहिलं काय तर SCR2 ऑन करायचा. कशासाठी? तर ह्या कॅपॅसिटरच्या चार्जिंगसाठी. सो दिस कॅपॅसिटर विल चार्ज fully. When it will charged fully, the current will stop. Current will stop means SCR2 off. Now there are still two loops are present for the current flowing. एक म्हणजे outer आणि एक म्हणजे inner. त्यावेळेस the combination of L and C starts oscillation. Oscillations means the positive negative. So for positive half cycle diode will be on, for negative cycle diode will be off. So When the capacitor starts discharging, the L is charging. L is going to start to store the charge. And once the capacitor is totally discharged होतो, तर एल मधली एनर्जीमुळं परत तो चार्जिंग व्हायला लागतो कॅपॅसिटर. परंतु ह्या वेळेस इट विल बी इन रिव्हर्स डायरेक्शन, म्हणजेच रिव्हर्स व्होल्टेज इथं प्रोड्यूस होतं. आणि हे रिव्हर्स व्होल्टेज SCR 1च्या अक्रॉस तयार होतं. SCR 1ला जर रिव्हर्स व्होल्टेज मिळालं की SCR 1 हा ऑफ होतो. अँड दिस इज व्हॉट द कम्युटेशन इज गोइंग टू हॅपन. कम्युटेशन म्हणजे ऑफ करणे. So this is all about the all the these four classes of this particular commutation part, and I hope this is the for all the parts of SCR we have covered till now. So in the next session we will see the remaining part, that is the track and diac. So this is all over about today's session, but just once again the reminder is that I will share one Google Sheet. So immediately uh, with up to 3 o'clock you have to just fill it that and give your opinion about physical presence in the college. Okay, so now you can just put your attendance and you can leave. Thank you.